In this video, we're going to look at using law of cosines to find angles and sides in oblique triangles. Remember, oblique triangles do not have a 90-degree angle in them. If you want to pause and write some of these formulas at the top of your screen down, please do so. Okay, let's go to this. We have a triangle given to the right of your screen. The only information that was given in this problem in the beginning was this typed information. Side A was 8, side B is 4, side C is 9. When you use law of cosines, we want to find the largest side, the longest side in order to find the largest angle. We don't have any angles at this point, so angle C is opposite of the longest side. Let's go get it first. At the bottom left of your screen, cosine of C is equal to a squared plus b squared minus c squared all over the product of 2ab. A is 8, b is 4, c is 9. Carefully plug these values in. This fraction results in a negative 1 over 64. If I go too fast in the video, please feel free to pause. Cosine inverse of negative 1 over 64 is 90.90 degrees, rounded to 2 decimal places. The next largest angle would be angle A. It's opposite of the next longest side. Make sure your calculator is in degree mode also. Cosine of A, that's equal to b squared plus c squared minus a squared. Notice the same letter is on the far ends. The other two letters are in the middle. So plugging your values in carefully results in 11/24 for this large fraction. Cosine inverse of 11/24, 62.72 degrees. Once you know two angles, you can subtract them from 180 to get your third. No matter if a triangle has a right angle or not, the interior angles always add up to 180. Okay, let's look at another example. For this particular diagram, we have a triangle, it's oblique. We were given two sides and the angle in between. In order to use law of cosines, we need to know at least enough information to complete our formula. Let's check out and see. We don't have any angles except for A. If you don't know the angle and opposite sides of both of the same letters, then you have to kind of use law of cosines. Now, if you do know both A's or both B's or both C's, then you can use law of sines because those fractions require knowledge of the same letter. Anyway, back to the problem. The only angle I have is 30 degrees, so I'm going to find side A first using the length version of law of cosines. A squared equals b squared plus c squared minus the product of 2bc cosine angle A. Substitute everything in that you can. I recommend typing this in all at one time, and when you hit enter, save all of your decimal values, as many as you can. Now this large number, 259, that's a squared. We need a, so we take the square root of it. Again, save several decimal places to maintain accuracy. And side A is about 16.11 units long. Angle B or angle C, we could go after them. I really recommend going after the largest angle that you can first. But just to stay in order, let's go with angle B. That's the one here in red. The law of cosines version, when you're looking for angle, it's the right column of those formulas above. If you need a side length, it's the left column of the formulas. Cosine of angle B is a squared plus c squared minus b squared over the product of 2ac. Substitute all your numbers in. If you have to use a rounded off number, use at least 2 or 3 decimal places to maintain some accuracy. The more the better. You don't always have to overkill it. This fraction divides out to 0.915. Now I went ahead and wrote several values in here. Basically what you'd want to do is calculate this fraction, put it in your calculator, and when you hit enter, save all the decimals. Cosine inverse of your answer gives us 23.79 degrees. And then from mere subtraction, once you know two angles, subtract them from 180. That's an obtuse angle of 126.21. Heron's formula is very useful in trigonometry. It allows you to find the area of a triangle if you know all 3 sides. I'm going to leave that formula up there. You work it in 2 stages. The first thing you do is you find the semi-perimeter. You add up all 3 sides, divide by 2. This semi-perimeter, lowercase s, is used multiple times in your area formula. One time it's a standalone value, but the next 3 you slowly subtract each side of your triangle from that semi-perimeter. Find the area of the triangle with A equals 45, B equals 44, and C equals 21. Add up all 3 sides, that's 110. Cut it in half, that's 55. 55 is halfway around your triangle. Using this value, remember it stands alone, and then you slowly subtract all 3 sides from it. Everything goes under a square root, and it's all multiplied together. So we're going to be calculating the square root of 55 times 10 times 11 times 34, 453.54 square units if you round to the nearest hundredth. We also did this one in class. Find the area of the triangle with the 3 sides given. No matter if the numbers are friendly or not, you still add them all up and divide by 2. The semi-perimeter for the triangle in this problem has a semi-perimeter of 17.76. Once you get your semi-perimeter, then you can go after the area. Semi-perimeter stands alone, and then you slowly subtract each side from it in the next 3 parentheses. Carefully type all those numbers in and be sure to square root. When you do, we get an area of 51.81 square units. To approximate the length of a marsh, a surveyor walks 440 meters from point A to point B. In the diagram, that's this distance from A to B, 440 meters. Then turns 75 degrees and walks 220 meters to point C. Find the length of the marsh, which is AC. Round to 1 decimal place. How many degrees are in a straight line? 180, very good. So here at this junction B, the surveyor is walking in a straight line until he or she turns 75 degrees, but that leaves 105 degrees in here because these 2 need to add up to a straight line. So we have an interior angle of 105, and we have 2 adjacent sides of 440 and 220. The length from A to C, I just marked it with an X. That value squared is equal to our side length squared and added together minus the product of 2 times our sides times cosine of the angle in between. Okay, that comes out to a really huge value. 292,107 and some change. Be sure to square root that value. 540.5 meters, that's an approximation of the marsh.